Now let us see some problems, numericals of this about what we have studied. See, first question is one. A parallel plate capacitor has plates 0.15 millimeter apart, a plate area of 0.1 meter square, and a dielectric of relative permittivity 3. If the charge on the capacitor plate is 0.5 microcoulomb, find 1. the charge density sigma. That is what it is asking. Sigma is equal to Q by A. That is very simple. Electric field intensity E you have to find out. Then potential difference across the plates. Okay. So now let us write down what are the data given. One is thickness of the plates. Thickness of the plates D is equal to 0.15 millimeter, and that is equal to 0.15 into 10 raised to minus 3 meters. Area of the plates A is equal to 0.1 meter square. Charge on the plates Q is equal to 0.5 microcoulomb, and that is equal to 0.5 into 10 raised to minus 6 coulombs. These are the data given. Now, what is the formula for first charge density? Charge density, what is charge density? Sigma. Sigma will be equal to Q by A. It's a very simple problem. So that will be equal to, what is Q? 0.5 into 10 raised to minus 6 by area is 0.1 meter square, that is equal to 0.5 into 10 raised to minus 5 coulomb per meter square. So this is the first answer. The first answer is 0.5 into 10 raised to minus 5 coulomb per meter square. Now let us come to the second question. What is the second question? Electric field intensity you have to find out. Electric field intensity E is equal to, what will be the electric field intensity between the two parallel plates? You can do it by finding capacitance also, you can find out, but I am doing an easy method. E is equal to sigma by epsilon 0 K. If it is vacuum, it was sigma by epsilon 0. If it is dielectric, is the epsilon 0 K. Here another data is also given, dielectric constant. K or epsilon R is equal to 3, that is given. So E will be equal to, what is sigma? 0.5 into 10 raised to minus 5 divided by 8.854 into 10 raised to minus 12. That is the value of epsilon 0 into 3. That will be equal to 18887 volt per meter. That is a unit of electric field intensity or Newton per coulomb, whatever it is. So this will be the electric field intensity. So answer of the second question is 18887. Say minus 7. This will become, and 5, I think this much only. Yeah, that's right. 7 volt per meter or Newton per Coulomb square. Newton per Coulomb. Now, let us see what is the third question. Third question is potential difference. How you will find the potential difference? Potential difference E into D. V is equal to E into D. That will be equal to E is 1.88 into 10 raised to 5 into D is, what is D? 15 into, 0.15 into 10 raised to minus 3. That will be equal to only 28 volt. 27 or 28 volt. That will be the answer. 27 point something you will get. That will be the answer. So third answer is 28 volt. That will be the third answer. So please note down. And so I am doing an additional thing also. What about the capacitance? How you will find out the capacitance? Capacitance is equal to C is equal to Q by V. What is Q? Q is equal to 0.5 into 10 raised to minus 6 divided by, what is V? 28. That will be equal to, you calculate how much it will be. Okay, that will be the capacitance also. Now let us look into another numerical. What distance apart the two plates each of area 0.2 meter into 0.1 meter, that is the dimension of the plate, of a parallel plate capacitor be placed in order to have the same capacitance of a spherical conductor of radius 0.5 meter. The question is this: we are having a parallel plate capacitor. Its dimension of the plate is, one is 0.2 into 0.1 meter. There are two plates like that. We don't know the distance D, and it should have the D has to be adjusted in such a way. What should be the D? What should be the separation? If it wants a capacitance equal to a spherical capacitance of radius 0.5 meter. Suppose the spherical capacitor, you have to find out what is the spherical capacitance of a sphere. Then you have to find that, you have to equate with the capacitance of the parallel plate capacitor. Understood? The question is that how much distance, in which, at what distance it should be kept. These two parallel plates should be kept in order to have a capacitance equal to a spherical capacitance of radius, conductor of radius 0.5 meter. Okay. Now let us see how to do it. What is the capacitance of a parallel plate capacitor? So let us write down what is the data given. Area of the capacitor, area of the parallel plate is equal to 0.2 into 0.1 is equal to 0.02 meter square. That is the area of the plate. Then it should have a radius of the sphere. R is equal to 0.5 meter. Now what is the capacitance of a parallel plate capacitance? We have Z is equal to, for a parallel plate capacitor, Z is equal to epsilon 0 A by D. This is the formula for a capacitance of a parallel plate capacitor. It is an air capacitor, so we have to use only epsilon 0. And what is the capacitance of a sphere? This is parallel plate. Is a 4 pi epsilon 0 r. This is the capacitance of a sphere, and this should be equal. That is, the condition is that epsilon 0 A by D is equal to 4 pi epsilon 0 r. Then what will be D? D will be equal to A by 4 pi r, and that will be equal to 0.02 divided by 4 pi into r is 0.5, and that will be equal to 3.18 millimeter. It will come into 10 raised to minus 3 meters. 3.18 into 10 raised to minus 3 meter. That is the answer. Please note down. Now let us see this question. A parallel plate capacitor is partially filled with an ebonite plate of thickness 6 millimeter. The area of the plates is 2 into 10 raised to minus 3 meter square, and the distance between them is 0.01 meter. Calculate the capacitance of the capacitor. Given the dielectric constant of ebonite is 3. So let us write down the data given. So area of the plates is equal to 2 into 10 raised to minus 3 meter square, and thickness of ebonite of dielectric. Here we use the term T. T is equal to 6 into 10 raised to minus 3 meter, and thickness of the separation of plates. That is D. D is equal to 0.1 meter. Okay. Now dielectric constant. K is equal to 3. It's a direct application question. What is C? C will be equal to epsilon 0 A by D minus T plus T by K. C will be equal to 8.854 into 10 raised to minus 12. That is the value of epsilon 0 into A. Area is 2 into 10 raised to minus 3 divided by, what is D? 0.1 minus 6 into 10 raised to minus 3 into 1 minus 1 by 3. You can calculate it, and the value of this will be 2.95 into 10 raised to minus 12 farad, or 2.95 picofarad. That will be the answer. Note down. Now let us look into another numerical. A capacitor consists of a dielectric of dielectric permittivity 4. The separation between the plate is 3 millimeter. When another dielectric of 5 millimeter is introduced in addition to the first dielectric between the plates, the capacitance is reduced to 1/3 of the first capacitor. Calculate the dielectric constant of the second dielectric. This is the figure. See, initially there was a dielectric, fully there was a dielectric of 3 millimeter thickness and a dielectric constant of 4. Initial case. Then it is having a capacitance. Now, another dielectric of 5 millimeter thickness is introduced in between them, and the capacitance is reduced to C by 3. It is 1/3. It is reduced to 1/3. So, what is the value of K of the second dielectric? So, what will be the capacitance of first dielectric? First capacitance, C will be equal to epsilon 0 K A by D, and that will be equal to 8.854 into 4 into area is not given, isn't it? A by thickness is 3 millimeter. 3 into 10 raised to minus 3. Okay, so this is the first capacitance, equation 1. And what will be the second capacitance? Second capacitance is C by 3. And what is the formula? C by 3 will be equal to epsilon 0 A by epsilon 0 A by, it is filled with the two capacitors, so T1 by K1 plus T2 by K2, and that will be equal to epsilon 0 A by, what is T1? T1 is 3 into 10 raised to minus 3 by K1 is 4 plus T2 is 5 into 10 raised to minus 3. That is 5 millimeter. Where it is? This is T2 and this is T1. So, epsilon 0 A into 3 into 10 raised to minus 3 by 4 plus 3 into 10 raised to minus 2 by K. We have to find out K. This is C. Then what will be C? C will be equal to 3 epsilon 0, taking 3 the other side, epsilon 0 A by 3 into 10 raised to minus 3 by 4 plus 5 into 10 raised to minus 3 by K. This is equation 2. Left hand side of both the equations are same, so we will get what we will get 8 point, or we can put simply epsilon 0 here. Epsilon 0 4 into A by 3 into 10 raised to minus 3 will be equal to 3 epsilon 0 A by 3 into 10 raised to minus 3 by 4 plus 5 into 10 raised to minus 3 by K. A and epsilon 0 will get cancelled. 4 by 3 into 10 raised to minus 3 will be equal to 3 divided by 3 into 10 raised to minus 3 by 4 plus 5 into 10 raised to minus 3 by K. Taking the to the other side, 4 into 3 into 10 raised to minus 3 by 4 plus 5 into 10 raised to minus 3 by k will be equal to 9 into 10 raised to minus 3. Okay. From this you can equate A, that is 12 into 10 raised to minus 3 by 4 plus 20 into 10 raised to minus 3 by k is equal to 9 into 10 raised to minus 3. From that you can take this other side, then you can calculate the value of k, and you will get the value of k as k is equal to 0.33. This will be the value of k. Okay, please note down.